The entire universe, everything you see, everything you are, every star burning in the night sky, every atom in your body, all of it came from nothing. Not from something small, not from something invisible, but from literally nothing at all. And here's the part that will keep you awake tonight, that nothing isn't what you think it is. Nothing is not empty, not peaceful, not absent. Nothing is the most violent, chaotic, creative force in existence, and understanding what nothing truly is will completely shatter everything you believe about reality. Prepare to discover that the absence of everything is actually the presence of something far stranger than you ever imagined. When we talk about the universe coming from nothing, we're not speaking metaphorically or philosophically. We're talking about hard physics backed by mathematics and observation. The prevailing scientific theory suggests that approximately 13.8 billion years ago, all of space, all of time, all of matter and energy, everything that exists burst into being from a state that contained none of these things. Before the Big Bang, there was no space to contain anything. No time for events to occur in, no matter or energy or forces or physical laws. There was nothing, and then suddenly, explosively, cosmically, there was everything. This transition from nothing to everything is the most profound mystery in all of science, and the answer to how it happened requires us to completely reimagine what we mean when we use the word nothing. Let's start with the everyday understanding of nothing. The kind of nothing you think about when someone asks what's in an empty box or an empty room. You might say there's nothing in the box, but of course that's not really true. The box contains air, molecules of nitrogen and oxygen bouncing around, photons of light passing through, neutrinos from the sun streaming through the walls as if they weren't even there, quantum fields permeating every point in space, gravitational effects from distant masses, and the fabric of space-time itself curving and flexing according to Einstein's equations. When we say a box is empty, we really mean it doesn't contain any solid objects we care about at the moment. But it's actually filled with an incredible amount of stuff we're just ignoring because it's not relevant to our immediate concerns. So that kind of nothing isn't really nothing at all. It's just nothing interesting from a particular limited perspective. True nothing, the kind of nothing that might have preceded the universe, would have to be far more extreme, far more absolute, far more genuinely absent of everything. So let's remove the air from our box, create a perfect vacuum with no atoms, no molecules, nothing material at all. Surely now we have nothing, right? Wrong, because even in the perfect vacuum of empty space, quantum mechanics tells us something extraordinary is happening, something so weird that it defies all common sense and yet has been experimentally verified countless times. The vacuum isn't empty, it's seething with activity, roiling with virtual particles that pop into existence in matter-antimatter pairs, exist for the briefest instant allowed by Heisenberg's uncertainty principle, and then annihilate back into nothingness. These aren't theoretical constructs or mathematical conveniences. They're real enough to have measurable effects. The Casimir effect, where two metal plates placed very close together in vacuum experience an attractive force, is caused by virtual particles. The slight shift in energy levels of electrons in hydrogen atoms, called the Lamb shift, is caused by virtual particles. The anomalous magnetic moment of the electron, measured to incredible precision, matches theoretical predictions that include contributions from virtual particles. Nothing, it turns out, is actually something, and that something is constantly creating and destroying particles in a frenetic quantum dance that never stops. But wait, we haven't achieved true nothing yet because we still have quantum fields permeating space. Modern physics describes reality as built from fields, fundamental entities that exist at every point in space and time. There's an electromagnetic field that gives rise to photons, a Higgs field that gives particles mass, quark fields and lepton fields and boson fields, all overlapping and interacting at every point in the universe. These fields have a lowest energy state called the vacuum state, but even in this state the fields still exist. They're still there, still real, still part of the furniture of reality. The particles we observe are excitations of these fields, like waves on an ocean, and even when there are no waves, the ocean itself remains. So, to get true nothing, we'd have to remove the quantum fields themselves, eliminate the very substrate from which particles arise. But here's where things get philosophically treacherous, because the quantum fields aren't something added to space. They are space in a very real sense, or at least they're inseparable from the structure of space-time. Removing them would mean removing space itself, and once you've removed space, you've also removed time, because according to relativity, they're woven together into a unified space-time fabric. So true nothing would have to be the absence of space, time, matter, energy, fields, physical laws, everything. This is the kind of nothing that supposedly existed before the Big Bang. Now here's where physics gets genuinely mind-blowing. Several prominent physicists, including Lawrence Krauss and Stephen Hawking, have argued that this kind of absolute nothing is actually unstable, that nothing inevitably decays into something, that the universe arising from nothing isn't just possible, but actually inevitable given enough time. Except time doesn't exist in nothing, so inevitability is a strange concept here. The argument goes something like this. In quantum mechanics, anything that isn't explicitly forbidden will eventually happen. Virtual particles pop into existence because nothing forbids it. Radioactive atoms decay because nothing forbids it. Quantum tunneling allows particles to pass through barriers they shouldn't be able to cross because nothing forbids it. The universe follows the principle that whatever can happen will happen given enough opportunity, and in the absence of laws preventing something from happening, that something becomes not just possible, but in a weird sense necessary. Nothing is unstable because there's no law of physics preventing something from arising from nothing. And in quantum mechanics, the absence of a prohibition is effectively a permission. The mathematics of this is fascinating and disturbing. In quantum field theory, we can calculate the probability of particles appearing from vacuum, and while the probability is usually tiny for any given location and moment, across all of space and all of time, even tiny probabilities become certainties. But when we're talking about the origin of the universe, we don't have space and time yet. Those are things that need to be created along with everything else. So how do you apply probability to a situation where there's no time for events to occurring? This is where different physicists diverge in their approaches. Some invoke quantum tunneling from nothing, suggesting the universe tunneled into existence the way a particle tunnels through a barrier, not by moving through the barrier, but by simply appearing on the other side without ever being in the middle. Others invoke the Hartle-Hawking no-boundary proposal, which uses imaginary time to describe the origin of the universe in a way that eliminates the initial singularity and makes the question of what came before meaningless, like asking what's north of the North Pole. Still, others suggest that our universe might be a quantum fluctuation in some larger meta-space, a bubble of false vacuum that nucleated and expanded, creating space and time as it went. But let's dig deeper into what quantum mechanics says about nothing, because this is where things get truly strange. The Heisenberg uncertainty principle, one of the bedrock principles of quantum theory, states that certain pairs of properties cannot both be precisely determined simultaneously. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. But there's another version of the uncertainty principle that relates energy and time. The shorter the time interval you consider, the larger the uncertainty in energy. For an infinitesimally brief moment, the uncertainty in energy becomes effectively infinite, which means that for the briefest instant, the universe can borrow essentially unlimited energy from nothing, use it to create particles, and pay it back before the universe's accounting system notices the deficit. This is why virtual particles can exist. They're energy borrowed from the vacuum's uncertainty, existing on credit for the brief moment that quantum mechanics allows before the books must balance again. Now extend this reasoning to the ultimate limit. In a state of absolute nothing with no time, the time interval is zero, which means the energy uncertainty is infinite, which means anything and everything can appear, including an entire universe complete with its own space-time, and there's no violation of energy conservation. Because in general relativity, the total energy of a closed universe is zero. The positive energy of matter and radiation exactly balanced by the negative gravitational potential energy. This leads to one of the most profound insights in modern cosmology. The universe is probably the ultimate free lunch. The total energy of the universe, when you account for both matter energy and gravitational potential energy, likely sums to exactly zero. All the positive energy locked up in particles and radiation and motion is precisely balanced by the negative energy of gravity pulling everything together. This means the universe didn't require any net energy input to create. It split zero into positive and negative components, creating something from nothing, not by violating conservation laws, but by maintaining perfect balance. It's like having a bank account with $0 and then simultaneously depositing $1 million and taking out a loan for $1 million. You've created a lot of activity and apparent wealth, but your net worth remains exactly zero. The universe did something similar, creating vast amounts of stuff, but keeping the cosmic ledger perfectly balanced at zero total energy. This is how nothing can create everything without violating any physical laws, by ensuring that everything sums back to nothing when you do the full accounting. Now, some physicists and philosophers object to this whole line of reasoning by pointing out that quantum fields, quantum fluctuations, quantum mechanics itself, these aren't nothing, they're something. If you need quantum fields and physical laws to get a universe from nothing, then you're not really starting from nothing. You're starting from a pre-existing framework of physical law and quantum possibility space. This is a fair criticism, and it leads to an even deeper question. Where do the laws of physics come from? Why does the universe obey quantum mechanics rather than some other set of rules or no rules at all? Why is there mathematics underlying physical reality? These questions push us beyond physics into metaphysics, into philosophy, into the ultimate why questions that science might not be able to answer. Some physicists like Max Tegmark suggest that mathematics isn't something the universe uses, but something the universe is. That physical reality is literally identical to a mathematical structure, and all possible mathematical structures exist in some sense. And we find ourselves in this particular one because it's capable of supporting observers like us. This is the mathematical universe hypothesis, and it's either profound or absurd depending on your philosophical temperament. Others take a different approach entirely and suggest that the question of why there's something rather than nothing might be based on a false assumption. Maybe nothing is actually impossible, maybe existence is the only option. Maybe non-existence is an incoherent concept that seems meaningful, but actually isn't. After all, for nothingness to be real, there would have to be a state of nothing, but a state is something, so you've already contradicted yourself. Perhaps existence is necessary and couldn't be otherwise. And the universe exists because non-existence is literally impossible, not just improbable or unstable, but logically incoherent. This line of thinking suggests that the question isn't why is there something rather than nothing, but rather why would we ever expect there to be nothing in the first place? Our intuition that nothing is more natural or more default or more likely than something might be completely backwards. Maybe something is the natural state and nothing is the impossible condition that could never obtain. But let's return to the physics and explore what experiments and observations tell us about nothing. The Casimir effect I mentioned earlier has been measured precisely and confirms that the quantum vacuum has real physical consequences. True uncharged. Metal plates placed in a vacuum experience an attractive force with no apparent cause. But quantum field theory explains this perfectly by noting that virtual particles of all wavelengths are constantly appearing and disappearing. In the vacuum and between the closely spaced plates, only certain wavelengths fit, while outside the plates all wavelengths are present. This creates a radiation pressure imbalance. More virtual particles pushing from outside than from between, and the plates are pushed together. This isn't theoretical speculation, it's measured reality, and it tells us that nothing is definitely something with structure and properties and measurable effects. The vacuum has energy, has pressure, has dynamics, all of which would be meaningless if nothing were truly nothing. Dark energy, the mysterious force accelerating the universe's expansion, might be another manifestation of the non-emptiness of nothing. Current observations suggest that about 68% of the universe's total energy density is in the form of dark energy, a uniform energy that fills all of space and doesn't dilute as the universe expands. The simplest explanation for dark energy is that it's the energy of empty space itself, the vacuum energy arising from quantum fluctuations, the zero-point energy of quantum fields. If this is correct, then nothing, empty space with no particles or radiation, actually has a huge amount of energy, enough to dominate the entire universe's dynamics and determine its ultimate fate. There's a problem though. When physicists calculate what the vacuum energy should be based on quantum field theory, they get an answer that's about 120 orders of magnitude larger than what we observe. This is called the cosmological constant problem, and it's one of the worst predictions in the history of physics, suggesting we're fundamentally misunderstanding something about nothing, about quantum mechanics, about gravity, or about how they fit together. The fact that we can be so wrong about nothing tells you how strange and poorly understood this concept really is. Quantum foam is another aspect of nothing that emerges when you take quantum mechanics and general relativity seriously at the smallest scales. At the Planck scale, about 10 to the minus 35 meters, quantum fluctuations in space-time itself become significant. Space and time stop being smooth, continuous entities and become foamy, bubbly, chaotic, with tiny wormholes and black holes and regions of twisted geometry constantly forming and dissolving. This quantum foam is what space-time looks like when you zoom in far enough, and it suggests that at the fundamental level, even the distinction between space and time breaks down into something more primordial and strange. Nothing, when examined closely enough, reveals itself to be a seething quantum chaos that only appears empty and calm when averaged over larger scales. It's like a calm ocean surface that reveals violent molecular motion when you zoom in far enough. Nothing is the same, calm when viewed macroscopically, violent when viewed at the Planck scale. Here's another twist. Recent developments in quantum gravity and string theory suggest that space and time might be emergent properties, things that arise from more fundamental entities rather than being fundamental themselves. In some versions of string theory, space-time is not the stage on which physics happens, but rather an approximation that emerges from the collective behavior of strings and brains and other exotic objects existing in a pre-geometric realm. In loop quantum gravity, space-time is woven from tiny loops of gravitational field, and empty space is just a particular configuration of these loops. In both cases, what we call nothing, meaning empty space with no particles, is actually a highly structured state of more fundamental entities. This suggests that our entire question about how something came from nothing might be based on a misunderstanding of what the fundamental stuff of reality actually is. Maybe there never was nothing in any absolute sense. Maybe there was always some kind of pre-geometric proto-reality from which space, time, and matter all emerged. The anthropic principle adds yet another layer to this discussion. Why does nothing have the particular properties it has, the particular vacuum energy, the particular quantum fields, the particular physical laws? One answer is that if nothing had different properties, we wouldn't be here to ask the question. The laws of physics have to be compatible with the existence of observers, because otherwise there would be no one to observe those laws. This seems almost tautological, but it has real explanatory power in a multiverse context. If there are many universes or many regions of space with different physical laws and different properties of nothing, then we necessarily find ourselves in one where nothing is such that something can arise, because we couldn't exist in a universe where nothing remained, nothing forever. This doesn't explain why there's a multiverse or why nothing can have different properties in different places. But it does explain why our particular nothing is the way it is, because we selected it by virtue of existing. Let's talk about what this means philosophically and existentially, because these aren't just abstract physics puzzles. They touch on deep questions about meaning, purpose, and our place in reality. If the universe came from nothing, if we're all ultimately quantum fluctuations in a void, if everything we are and everything we'll ever do is a temporary deviation from nothingness that will eventually decay back to equilibrium, does that make existence meaningless? Some people find this idea depressing, suggesting that if we came from nothing and return to nothing, then nothing we do matters. But I think that's exactly backwards. The fact that something arose from nothing, that complexity and beauty and consciousness emerged from void, that the universe spontaneously organized itself into stars and galaxies and planets and life and minds capable of understanding their own origins. All of that is miraculous precisely because it wasn't guaranteed. Because it emerged from pure possibility without any pre-existing purpose or plan or necessity. We're not following a script, we're improvising existence itself, and that makes what we do more meaningful, not less, because we're creating meaning where none existed before. The connection between nothing and quantum entanglement opens up even stranger possibilities. Entangled particles share a quantum state such that measuring one instantly affects the other regardless of distance, as if they're connected by invisible threads that transcend space. Some physicists speculate that this entanglement might be fundamental, that the whole universe might be a single entangled quantum state that arose from nothing, and that separating anything from anything else is impossible at the deepest level. We're all connected not by mystical forces, but by quantum correlations that trace back to our common origin in the initial quantum fluctuation that created everything. When you look at a distant star, the photon entering your eye is entangled with the atom that emitted it, and both are entangled with the quantum state of the early universe. And ultimately, everything is entangled with everything else in a vast web of quantum correlations that make the universe a single unified system, despite appearing to be made of separate objects. Nothing gave birth to this unified whole, and perhaps nothing remains unified in a way that transcends our everyday experience of separation and distinction. Recent experiments with quantum vacuum manipulation have shown that we might be able to extract energy from nothing, not in a perpetual motion machine sense that violates thermodynamics, but in a controlled way that taps into the quantum fluctuations of the vacuum itself. The Casimir effect can in principle be used to generate small amounts of energy, and more exotic proposals involve manipulating the quantum vacuum to produce thrust for spacecraft, to create exotic materials with strange properties, to probe the structure of space-time itself at quantum scales. We're just beginning to understand how to engineer nothing, how to treat the vacuum not as empty space but as a manipulable medium with structure and properties that can be exploited for technological purposes. This suggests that nothing, far from being absent or void or empty, is actually the richest, most energy-dense, most fundamentally important aspect of reality, the foundation from which everything else arises and to which everything returns. What does it feel like to be a pattern of complexity temporarily emerged from nothing and destined to return to nothing? That's what you are. That's what we all are. Self-organizing. Patterns of matter and energy that arose from quantum fluctuations and will eventually dissolve back into equilibrium. Your consciousness, your memories, your hopes and dreams and fears, all of it is nothing elaborately arranged into something for a brief cosmic moment before the arrangement dissolves. Some find this realization horrifying, a confrontation with the apparent meaninglessness of existence. Others find it liberating, freeing them from the weight of cosmic importance and allowing them to create their own meaning in the space that nothing has temporarily opened up. I find it awe-inspiring. The fact that nothing can do this, can organize itself into galaxies and minds and music and love, suggests that nothing contains infinite potential, that absence is paradoxically the source of all presence, that void is pregnant with every possibility. We are nothing's way of experiencing itself, temporary windows through which emptiness gazes at its own creativity. The ultimate fate of the universe might be a return to nothing, though what kind of nothing remains uncertain. If dark energy continues to accelerate the universe's expansion forever, we'll end in a cold, dark, dilute state called heat death, where all structures have dissolved, all stars have burned out, all black holes have evaporated through Hawking radiation, and nothing remains but a thin soup of photons and neutrinos spreading ever further apart in an ever-expanding void. This is sometimes called the Big Freeze or the Big Rip, depending on the details. But either way, it's a return to something very much like nothing. Perhaps not the absolute nothing that preceded the universe, but a practical nothing where nothing interesting can ever happen again. Other scenarios like the Big Crunch where the universe collapses back on itself, or cyclic models where universes expand and contract eternally, offer different endpoints, but most of them eventually return to states of high symmetry and low complexity that resemble nothing more than something. The universe's story might be a journey from nothing through something back to nothing, a brief chapter of complexity sandwiched between eternities of void. But maybe that's not the end, because if nothing is unstable, if nothing inevitably produces something through quantum fluctuations, then perhaps the return to nothing is just a setup for another Big Bang, another universe, another attempt by nothing to create everything. The cosmological principle of eternal inflation suggests that quantum fluctuations in a high-energy vacuum state can continuously create new bubble universes, each with its own Big Bang, each expanding into its own space and time, each potentially with different physical laws and different properties of nothing. In this view, our universe is one bubble in an infinite froth of universes constantly being created by the instability of nothing. And the process never stops. Nothing is always and forever creating something, and something is always eventually returning to nothing, and the cycle continues eternally without beginning or end. This transforms nothing from a state to be explained into an eternal creative principle, the source and destination of all existence, the alpha and omega of reality itself. So what is nothing? Nothing is not the absence of everything, but the presence of pure potential. Nothing is not empty, but full of possibility. Nothing is not stable, but dynamically unstable, constantly creating and destroying virtual particles, constantly fluctuating, constantly exploring all possible configurations of matter and energy and space-time. Nothing is not separate from something, but intimately connected to it, the ground state from which excitations arise, the canvas on which reality is painted, the silence between the notes that makes music possible. Nothing is not nowhere, but everywhere, underlying every point in space, present in every moment of time, the substrate of existence itself. Nothing is not nothing at all, but rather everything in potential. All possibilities superposed, all configurations available, all of reality compressed into a state of unrealized potential, waiting for quantum fluctuations to make it actual. Understanding nothing means understanding that the fundamental nature of reality is not being but becoming. Not substance but process, not static existence but dynamic emergence. We came from nothing and we're still emerging from it with every passing moment. Reality continuously creating itself from void. Existence continuously choosing itself over non-existence. Something continuously arising from nothing, not once at the beginning, but always, now in this moment and every moment, the eternal miracle of presence arising from absence. If your mind feels like it just collapsed into a quantum singularity of confusion and wonder, then you're exactly where you need to be. Smash that subscribe button right now, because we're just getting started exploring the deep mysteries of existence, the questions that make you question everything, including whether questions themselves make sense. Drop a comment telling me what you think nothing really is. Whether the universe could have come from absolute nothing, or whether there's always been something in some form. And what it means for your life that you're a temporary pattern of complexity emerged from void. Hit that like button if you want more content that doesn't just teach you facts, but fundamentally rewires how you understand reality itself. Because the universe is stranger than we suppose, stranger than we can suppose. And nothing is the strangest thing of all precisely because it's not really nothing, but rather the source of everything. Thanks for joining me on this journey into the void, and remember, you are nothing elaborately arranged into something, and that's the most amazing fact in existence. See you in the next video, where we'll continue exploring the cosmic mysteries that define reality itself.